Dr. Nafarizal bin Nayan and Dr. Riyaz Ahmad bin Muhammad Ali, and my supervisor Professor Madhya T.S. Khairul bin Ahmad. My name is Nyaanalechumi Vijayan. My metric number is CE160140. My final year project title is Zinc Oxide Nanoflower for Photocatalytic application.
What is zinc oxide? Zinc oxide is inorganic compound. Zinc oxide is a white color powder that is insoluble in water. What is nanoflower? Nanoflower are a special category nanoscale material containing a special combination of elements which when viewed microscopically resemble flower. What is photocatalysis? Photocatalysis is the most effective method used for water treatment. Nowadays, water is the most important to the world. But with industrial growth, water pollution occurred due to some company dispose chemical contaminant toward water. To overcome this problem, photocatalytic nature approachable have remained used in many fields such as ecological purification, self-cleaning, and etc. To solve this problem, zinc oxide have tremendous properties as a photocatalyst, such as low rate, great redox potential, non-toxicity and environmentally friendly structure, wide band gap, wide excitation banding, can retain bigger UV range, quick movement of electrons. Problem statement. A huge number of wastewater pollution are found in overflow from dyestuff. Zinc oxide is a rapid recombination of photo-generated electron hole and it only active with UV light and undergoes from photocorrection. Zinc oxide has photocorrection in photocatalytic application. Zinc oxide will not able to achieve more suitable electrochemical sensing. To overcome this limitation, zinc oxide has to combine with other materials such as metal, semiconductor, and nanocarbon. Objective of this project is to fabricate the production of zinc oxide nanoflower powder using hydrothermal method, to optimize the structural and morphological properties of zinc oxide nanoflower powder. Third, to apply the use of zinc oxide nanoflower powder in photocatalytic application. Scope of project. This project focus on prepare zinc oxide nanostructure using hydrothermal method. The zinc oxide nanoparticle investigate using field emission scanning, electron microscope, FESAM, X-ray diffraction, XRD, study the structural characteristic and UV visible to study photocatalytic activity. Morphologists carry the vitality required to grow the interfacial area and shape later nanoparticle. It has been accounted for that measure influence the phase composition. The study the photocatalytic effect, the ZNO nanostructure was studied through UV visible spectrum photometer. This project large amount of zinc oxide nanoflower powder will prepare using low cost hydrothermal method. Literature review. This is the example shape of nanoflower we will obtain in this project. Important application of zinc oxide nanostructure. First application is nanoelectronic, such as field emission, field effect transistor, solar panel system, nanogenerator. Second application in nanochemicals, such as chemical biochemical sensor, photocatalyst. Third, optoelectronic, laser diode, photodetector, optical device, data storing, light emitting diode. This is the summary of the method to obtaining zinc oxide nanoflower powder. There are few methods to obtain zinc oxide nanoflower powder. There are hydrothermal method, cold precipitation, solar gel, microwave acetated technique. To obtaining the zinc oxide powder, there are different methods and different synthesis conditions, and also properties and application. Next, I would like to present methodology. This is the flowchart operation process for zinc oxide nanoflower for photocatalytic application. Next, this is the flowchart of hydrothermal process to prepare the zinc oxide nutrition solution. In this project, we will prepare 4 samples with different concentration. They are 10 millimole, 30 millimole, 50 millimole, and 70 millimole. Next, this is the X-ray diffraction pattern of zinc oxide powder sample prepared to hydrothermal method. From this result, we can see that sharp brass peaks were recorded in between 30 to 40, which consist only vertex structure of zinc oxide peaks. From this hexadic pattern of crystalline zinc oxide structure show at 31.67, 30.45 and 36.13, which are related to the lattice plane 010, 002, 011. From this graph, we can observe that 50 millimole concentration as it gives the highest crystallinity, and it was the lowest value of full width at half maximum. Next, this is the table for value of full width at half maximum for zinc oxide nanoflower array from XRD analysis for the 50 millimole. Next, this is the field emission scanning electron microscopic of zinc oxide nanoflower grown for 50 millimole. So we can say that PSM is used to identify the surface morphology of prepared vertex structure of zinc oxide powder. These 3 images indicate that different view of magnification. From this, we can see that we can observe the growth mechanism that was studied flower-like structure. Zinc oxide can produce using hydrothermal method. So from this, we can say that when the concentration increased, the nanoflower grown also increased. This is the summary of previous study that proved that zinc oxide as a photocatalytic application. This is the sum of research paper that they have done the methylene blue test to prove zinc oxide as a good photocatalyst. Next, this is the example diagram of a previous research paper that proved that methylene blue test. Therefore, zinc oxide nanoflower can work as the effective photocatalyst, which prompt the potential application of our zinc oxide nanoflower to the treatment of wastewater. When photocatalyzed zinc oxide is illuminated by UV light with energy greater than or equal to its band gap valence band, electrons are promoted to the conduction band, leaving a hole. The UV spectroscopy of photocatalysts were tested using methylene blue. From this observation, we can see that zinc oxide nanoflower grown with different concentration through hydrothermal method have different degradation efficiency of methylene blue dye. The factor affected the efficiency degradation rate is by density, thickness and defect state. From this, the photocatalyst samples show the highest degradation percentage of methylene blue in presence of zinc oxide under UV light irradiation. From this, we can see that the methylene blue deep color changed to colorless. So we can conclude that zinc oxide nanoflower, zinc oxide is a good photocatalyst and have a prospective application in the wastewater treatment. Conclusion: zinc oxide nanoflower were fabricated using low-cost hydrothermal method. The XRD patent clarified zinc oxide nanoflower grown up at 90 degree was pure voltaic structure with satisfactory crystallinity quality. The XRD pattern of zinc oxide powder are revealed that vertice which links to the different peaks from that. Well known, the vertice 002 crystal structure as excessive crystallinity. The nanoflower of zinc oxide nano powder presented in the FEE images. Beside that, when the concentration of zinc oxide powder solution increased, the size of nanoflower also increased. Therefore, zinc oxide is a good photocatalyst and a prospective application of zinc oxide nanoflower in the wastewater. There are few recommendations. We can continue in future work. Use different type of chemical as reducing agents such as dope, zinc oxide with other material to enhance the crystallinity, structural, morphological and any other properties. Next, we can produce zinc oxide to co-precipitation method. UV light must be able to reach the zinc oxide. The process is restricted by the purity of the water being treated. This is the image of sample powder prepared through hydrothermal method. Thank you.